Hey everyone, welcome to this video where I'm going to be talking about MLflow Project. MLflow Project is a convenient way to package up your code, be it an entire pipeline or a single file. It ensures that your code is reproducible so that anybody can run it pretty much on any platform. So let's consider the steps of any ML project, where we load the data, pre-process it, do some hyperparameter tuning, train the model, and then do the evaluation on it. We can augment this project by using MLflow to store different parameters in the hyperparameter tuning stage and then also save their according metrics. We can also save the models if we want, or we can save just the final model that is the best. If we want, we can save the entire data set, or at least the locations of the data, so that we know which particular files were used. And in addition, we're going to save all of the metadata, so we'll know how much it took to run this step, when did we run it, and who ran it. In addition to all of this, MLflow Project is going to give us a nice way to package up our code. To use it, we'll need to specify a few files. So first of all, we're going to need ML project file, which is a YAML styled file that contains project name, environment file name, and a list of entry points for the script. We're going to need the file which describes our Python environment. In this particular case, I'm going to use Anaconda, so it's going to be called conda-environment.yaml, and it's going to have my version of the Python and all of the packages that I've used in the project. And finally, we're going to have a list of Python files, which are going to be these steps in our pipeline. They can be factored or reformatted however you want. However, they need to be Python files, so no Jupyter notebooks allowed here. Now let's see how I used MLflow projects in one of my example projects. First things first, just go to my tutorials MLflow projects file and copy or pull the entire repo. You're going to need it if you want to run this example side by side. As you can see, I already have it in my computer and I'm inside MLflow project. So when I call ls, it's going to give me ML project, conda environment YAML, main.py, and a folder called steps. And then also I'm going to have a data folder which you don't have yet, but you will get it once you run the pipeline. Now let's open this folder using VS Code, or you can use any other preferred code editor. And let's go through each of these files step by step. So the first file that I talked about was ML project. As you can see here, it specifies the name of the project. Here it's called fraud detection. The conda environment file, which specifies the name of your conda environment that you want to run the project in. And then it specifies the entry points. So in this particular case, I have only one entry point. In theory, you can have as many as you want. In this case, it's called main, so it's going to be my main pipeline that I want to run. It has two parameters that I want to specify. The first one is dataset, because I'm going to be pulling data from Kaggle. So you will need to specify whichever dataset you want to have here, but feel free to just follow along the example and use this dataset for fraud detection. And then second parameter is number of trials. It's going to be specific for hyperparameter tuning, so for how long do you want to run it. And then as you see, the command that this entry point is going to run Python main.py, and then it's going to insert this data set and number of trials parameters. And that's as easy as that. Specifying this file is not really complicated, and as I said, ML project is more of a convention than anything else, so nothing really crazy is going on here. Now let's take a look into the actual conda environment file that I'm going to be using. As you can see, here I'm specifying the name of this environment is going to be called fraud, but then also I'm specifying the dependencies. So first of all, my dependency for Python, and I specify a concrete version here, it's 3.9. And then under the pip, I specify which exact packages and their versions I want this project to install. So as you can see, you can specify the exact version like I did with MLflow. So it's going to be above or equal to 2.1, or you can just not specify any version and then it's going to pull the latest one. Usually it's the best practice to specify the exact version, but here I was too lazy, so I specified it only for MLflow. And these are basically the main things that we want to have to make sure that our project is reproducible. So ML project is going to specify how the computer needs to read the project, so how it needs to read this particular file. And then conda environment specifies in which Python environment to run this file. Now let's see the actual file that we're going to run. If you remember entry points we had, it's going to run main.py. So let's take a look what's happening there. And here, as you can see, I have my pipeline function. So in this function, I'm combining multiple steps that you're going to see later in the steps folder. As you can see here, they are load raw data, pre-process data, tune model, and then train model. They correspond to the steps that we've discussed previously. And here, after each step, I'm exporting something that I need for the next step. So for example, here, when I load raw data, I output its location so that my next function can use this information. In theory, we could store it somewhere else. We could store it maybe even in MLflow itself under the parameters. But in this case, I just wanted to pass them along the pipeline. Then I'm going to pre-process the data, and what it takes as inputs is the file location that we had previously. And after pre-processing the data, I again have file directories. So that's the location of the pre-processed files. And as you see, the following is quite simple as well. In the tune model function, I'm passing along the directories of training and validation data and outputting the best parameters to use. And in the final step of training the model, I'm using these best parameters together with all of the training and validation and testing data to train and evaluate my final model. And as a final step, this pipeline is going to print out that the final model is trained, and here are its metrics. So when we run main.py, as specified in the entry point, it's going to run this pipeline function. Before we go into each of these steps, let's just start running it. And because it's going to take some time for the data to download and for the hyperparameter tuning to finish running. Before running it, actually, let's launch the MLflow UI. What it's going to do is going to launch MLflow locally so that we can go to this location and track our experiments. Right now it's empty, but we're going to fill it in soon enough. And now that we have opened MLflow, let's run the pipeline itself. So what I'm going to do, I'm going to run the MLflow.ui. I'm going to call MLflow run dot. So I want to run this project in this folder, and I'm going to specify an experiment name, and it's going to be called fraud. And then I'm also going to specify that I don't want to run 10 hyperparameter tuning rounds because it's going to be too time consuming. So I'm going to run just 2, just to showcase that it actually works. So to do this, I need to do -p and then number of trials equals 2. Be careful with underscore and dashes and minuses and all that type of stuff. Like, it's very sensitive to these parameters. So let's hit run. So let's hit enter and wait until it finishes running. You will see a few things when it runs, and you will know that it's successful. First of all, it's going to start executing Python main.py using the parameters that we specified. So here is the data set that we had in the ML project file. And then 2, as you can see, is the number of trials that we specified before. Even though the default was 10, I've overridden it as 2. And you can see that data was loaded, everything is good. For you, it's going to take some time to load the data because it's going to download it from Kaggle. Also, make sure to set up your Kaggle JSON key correctly. If you don't know how to do this, there is going to be a link in the description for a GitHub page that explains it. The pre-processing step that runs after downloading the data is going to check for the proportion of the missing, and here it is, everywhere is 0, so it's a very clean data set. Otherwise it would just drop the columns which have too much missing data. And it's going to also drop a column called device fraud count because it was static. And as we can see, it informs us that the data is processed. And now it's going to enter the tuning stage. So we have prepared all of the data and we're ready for training. Well, when it starts tuning the data, it's going to create separate experiments. And let's actually go to the UI so that you know what I'm talking about. So here you can see it created 2 experiments. One of them was flawless oaks. And this is the actual kind of pipeline run that we created when we hit the MLflow run. But because we're going to be running some of hyperparameter tuning and training, we need to create separate experiments to store these results. And that's why they're going to be listed separately. You can configure it this way that the consequent runs are going to be sub-runs of this kind of parent main.py. But this case I decided not to do it. It seems overcomplicated and it would just be for you to have it displayed nicely visually, but it doesn't make sense to do it otherwise. And as we can see, it started storing the depth, learning rates, and then minimum data in leaf. We can add some other columns as well. We could add, for example, subsample. It is also something that is going to optimize, I think, yeah. And now let's wait until it finishes training all of those 2 runs, and let's see which hyperparameter set is going to win. So after some time, these 2 runs have finished training. As you can see, one of them took 1.9 minutes, another one took 3.1 minutes. So again, that's a benefit of MLflow. It tracks this stuff for you. And as you can see, the shorter run actually is superior in terms of validation, PR AUC, and also ROC AUC. So that's a nice sign. And we can see that out of these 2, this was the winning set of parameters. So what's going to happen now is going to grab these best params and it's going to train the final model. As you can see, it passes them right here. So it's going to take the best params, it's going to augment them with number of estimators and objective, and we need to add them because these 2 parameters were actually not tuned, they were constant. Then we pass these best params to the train model together with all of the file directories, and it's going to output to us the ROC AUC and PR AUC now on the test set. And actually the test set is going to be stored kind of separately from the validation set, but we'll see it later. In this console, you're going to see that the hyperparameter tuning is finished, and now it's going to start training the model. Now, when the model has finished training, you will see that the final model is trained. You will see the final test set metrics. So ROC AUC is 0.89 and PR AUC is 0.194. And if we go to the MLflow UI, we can see that this has been added to our metrics. So we can see these exact metrics inside of the MLflow UI. But here we can also see that the model was saved, and we can actually click on it and we can load it like this if we want. You saw how to use MLflow Project to run this pipeline. If that was all that you were interested in, feel free to finish this video. I'm going to do a quick rundown the exact steps that were running in this pipeline so that you have a better idea of how to write this yourself. So as you can see, in these steps we have download data, pre-process data, tune model, and then train final model. So inside of downloading the data, there is nothing fancy. We're just calling the Kaggle API to download data, and it checks if the Kaggle API key was configured correctly. And once it has been downloaded, it's going to output a CSV location of where it is stored. And where it's stored, it's actually the data folder. So that's why I already had it, because I ran this pipeline before and it has downloaded this for me. So it's not going to re-download it when your folder already has this data. So it's going to save it into data, raw, and then it's going to save base, variant 1, variant 2, etc. You can use basically any of these variants you want. I'm choosing the base, which I'm specifying here. The next step is going to be pre-processing the data, and here you can see the functions that I'm using to pre-process nans and to drop static data, and then also to do the training, validation, and test splitting. I'm using Polar's library here, which is kind of a replacement for Pandas, and it's written in Rust and it's super fast, and I'm actually a big fan of it, so I might do videos later about Polars because it's really amazing. And inside of the pre-processing data, this is kind of the main function that gets run. I'm just reading the CSV, pre-processing nans, then dropping the static features, and then doing the splitting here. And the important part here is to actually save these locations and pass them to the next step. So with these locations, I'm going to the tuning the model. And when I tune the model, I'm using Optuna library here. And you can see the objective that I'm doing here. And all of this stuff is kind of basic, and it is kind of boilerplate for cat boost. And I'm tuning some of these parameters available, so subsample, learning rates, regularization, and other ones. The important part here is to specify all of this stuff. I know it's not pretty, but it was kind of the easiest way to configure it for me. Make sure that all of them run in kind of the same location, but at the same time related to the main ML project run that we have. I know it's a bit crazy. Maybe there is much better way to do this. So if you know, let me know in the comments, please. As we saw in my previous video about MLflow, and if you haven't, check it out. I need to specify the MLflow context, with only difference here that I'm actually specifying the run ID myself instead of it being created automatically. And under this context, I can log the parameters. So that's the parameters that get stored. And then I also log my metrics. And these are the metrics and parameters that get stored here. So we can see it stores validation PRUC and validation rock UC, and then it stores all of these parameters that we were tuning. At the end of this function, we're passing our best trial parameters to make sure that we train the best possible model. So in the final step, it takes these parameters as input together with the locations of the folders, and using this utility function, I'm just reading in the CatBoost dataset. And here we can see the same pattern. So I need to specify all of this mumbo jumbo here before actually doing with MLflow start run. But the run ID gets specified here. And here again, we're logging the metrics, except instead of validation PRUC, we're storing test rock UC and PRUC. This is important because they're going to be different because it's two different evaluation sets. I'm also storing the parameters like I did before. And then I'm also going to be logging the model. So what it does, it basically saves the model inside of the MLflow artifacts. Which is quite a neat thing because then you can reload it whenever you want using the run ID that we can get from clicking to CatBoost and seeing it here. So we can see that by going to runs, by going to here and the CatBoost model, this is the location of it and we can load it. So that's it. To summarize, ML Project is a convenient way to package up your project to make sure that it's reproducible. To use it, you need to specify your ML project, and we can see it here. You need to specify your environment. In this case, I used Conda, but it can also be just by environment, or you can even use Docker if you want. And then you need to write the actual script that's going to do whatever you want. And you need to specify it as an entry point inside of your ML project. And then keep in mind that if you want to log additional stuff, like I did with hyperparameter tuning or training my final model, you need to do a bit of readjustments with your MLflow start run to make sure that you specify the actual run ID of this ML project. So I hope you liked it. I hope it was quite clear. If it's not, let me know in the comments. I will be experimenting with other MLflow functionalities and maybe I will move on to some other tooling as well. So yeah, let me know what you think, and don't forget to like, don't forget to subscribe, and I'll see you in the next one.